I'm Jay Boisseau, the AI and HPC technology strategist for Dell EMC, and I'm here with my friend Bill Magro, the chief technologist for HPC for Intel. So Bill, we're going to talk a little bit about the convergence of AI and HPC. Everybody loves to use that expression, but you and I have maybe a more precise way to describe that. So why don't you share your view on this convergence of HPC and AI?
Yeah, I think talking about HPC and AI convergence is a really kind of succinct way to describe what's going on, but it's really more about people recognizing that AI is an HPC workload and so can land on and benefit from high performance infrastructure. Right. And even more importantly, AI is becoming an essential tool alongside simulation and modeling. It's part of the workflow in scientific and engineering discoveries. So it's really more about the convergence of the infrastructure or an infrastructure that can support all these workloads than the AI and HPC really becoming the same thing.
Yeah, I wish people would refer to it as the workload differently than the solution.
Right.
The workloads include parallel simulation, data analytics, AI, and then the solution type is HPC. We use HPC for parallel simulation, use HPC for high performance data analytics, use HPC for deep learning training. Right. And yeah, I totally agree with you. We're seeing the workloads start to have a confluence as people are learning how to do simulation combined with deep learning. But that underlying solution is HPC. But there's still challenges because the way people run parallel computing jobs is often different than the way data scientists want to interact with systems. So can you talk about that a little bit?
Yeah, absolutely. So there's been a ton of innovation over recent years in AI, in data analytics, and of course the innovation that's existed in simulation modeling and traditional high performance computing for some time. But as the innovation occurred, the infrastructure they did that on, the infrastructure that it developed was really quite distinct from what we do in high performance computing. So now as people are getting more and more value out of analytics, more and more value out of AI, they're asking harder problems of the tools, which are turning these into HPC workloads. And as a result, they're outgrowing that infrastructure. So that's why people are looking to take AI and analytics and bring them into high performance infrastructure or traditional HPC systems, because they can benefit from that. But when you do that, all of a sudden the frameworks and the libraries have been designed for a different environment. So we need to bridge them in so that they work and they can coexist with the existing simulation modeling workloads.
Right, I know you guys and we have engineers that are both looking at how you can get optimal performance from scalable frameworks over multiple nodes for AI, just as we're doing optimal performance for scalable parallel simulation workloads. But you've still got that difference in the culture of the resource management systems and such. So our HPC users prefer these batch scheduling systems so that they can get huge jobs scheduled with some degree of priority on these systems, and some of our AI users are coming straight out of enterprise where they're used to being interactive with Excel and certain data science packages, and they're more in the container world and the Kubernetes world. And so you want to talk a little bit about how we develop a converged platform for the confluence of those two different communities?
Yeah, absolutely. I think you said it, is the expectation, and it's a cultural issue, but it's really not a new problem, right? Many years ago, people had large resources and individuals would log in and they would send emails to share it before workload sharing systems existed. And so, and there was a lot of waste of resources, right? And today we have tremendous utilization, tremendous efficiency that comes from people working in an environment that's interactive and having it complemented with a batch-oriented environment. I think the same thing is going to emerge for analytics, where there's a sandbox where algorithms can be developed, data cleansing methods can be applied, and then when the time comes to really apply it to the big data and do the big runs, they take advantage of the batch system. So there, the resource managers simply need to understand how to interface with these and create workload mobility between those two environments.
Agree completely. If we can figure out how to configure the workload managers to support these different environments, and I like the point you made. We've always actually had that problem in traditional HPC. We've had the people that wanted to run lots and lots of small jobs, trying to compete on the same HPC platform with people that wanted to run hero jobs and very large jobs. And so the challenge, of course, is in marrying these very different types of schedulers, these Kubernetes orchestration management systems for containers versus Slurm on these bare metal and the like on these bare metal clusters. So how do you see that playing out? How do you see the system software stack supporting both of those types of tools on bare metal clusters, bare metal with containers, et cetera?
Yeah, I think all the analytics and AI frameworks really can understand this, the cloud type of resource managers, where they're very dynamic and so on. And I don't think we can provide that environment and meet that expectation every day for every user in an HPC environment. So as a result, we need to either teach the frameworks how to talk to an HPC resource manager, or I think it's going to be a better path to teach the HPC resource managers how to speak to those frameworks. And so that provides the mechanisms and allows things to coexist, allows us to create workflows that combine all these very valuable techniques. But then ultimately, an administrator needs to apply policy, because running a center is all about being fair, but who gets to decide what's fair? And ultimately, you have competing desires. So having the right mechanisms to implement and apply the policy that makes sense in your environment is going to be the way things go.
Yeah, I think that's key. You can't please everybody all the time. Right. Everybody wants their job to run first.
Right.
But yeah, right. In HPC environments, traditional ones, we've always had this policy mechanism, often fair share policies and whatnot, to try to get the majority of the workload through with some degree of priority for large jobs or throughput or whatever as the case may be that week at that time for whichever researchers. The Kubernetes system is a very different model, but we'll have to figure out how to marry those kinds of systems and have site level policing that shares the resource, but that allocates the resource to the jobs in an appropriate way based on the workload balance for that user community and that workload at that time. I think there's a lot of work to do in this space. We certainly have many users that buy HPC systems, traditional HPC systems for parallel simulation, and that buy more AI-focused systems for that workload. It's going to be really interesting to see, since the hardware already looks essentially the same, it's going to be interesting to see how we migrate these, the software environments, the schedulers and resource management systems to be a more unified approach for the diversity of these workloads.
Yeah, I mean, the easy thing to do is say, well, there's infrastructure differences, there's expectation differences, and so I'm just going to build two systems. But that immediately leads to inefficiencies in terms of utilization and loss of flexibility. And so bringing those onto a common environment has clear benefits, but the resource managers and the policies have to evolve to make it's simple for administrators and users to use the right resources at the right time.
And so do you believe that the traditional HPC resource management systems will evolve to support these new emerging data science type of culture and workloads, that the Kubernetes type orchestration management systems will evolve to meet the more traditional parallel simulation workloads, or both? Or will there be an underlying infrastructure that allocates nodes dynamically between those two types of resource management systems?
All of those are happening
All
already.
of those are happening. Yeah. Do you have any feel for which you think is going to be more popular in different verticals? So, in enterprise versus academia versus government?
I think it really depends on the environment. In the end, there are going to be use cases for all. If you're running a private cloud, you're going to want to use cloud technologies to partition things and then establish next level resource management above it. If you're an HPC center, you probably want to have a HPC resource manager as the base layer and maybe deploy Kubernetes above it. So it's going to be mixed, but the key is that it's hierarchical and that things layer.
Great, well thanks for sharing your thoughts with me today.
Oh, thank you, Jay.
Appreciate it.
Great to be here.
So if you want to find out more about high performance computing solutions at Dell and how the platforms are converging to support AI workloads, please check out dellemc.com/HPC.